Welcome to a very quick video on bearings. Some of you guys have been asking for help with bearings, so I thought I'd solve a few questions, hopefully to provide some guidance on how you can approach bearings questions as well. So let's get started. Sketch P on a compass rose if P has a bearing of 132 degrees from T. So let's say this is T right here, T, and because it says from T, we draw a compass rose over here. We draw a circle, or you don't have to necessarily draw a circle, you just have to draw something like this. And then we're going to start measuring clockwise in this direction. But how much degrees do we actually need? We need 132 degrees. So 132 degrees will be around that direction, because from here to here is 90, and then 132 is less than 180, so it's less than directly going south. So it'll be roughly around over there. That's 132 degrees roughly. And to some point P. P has a bearing of 132 degrees from T. And so that's A done. Let's look at B. And once again, P has a bearing of 260 degrees from M. So let's say this dot over here is M. And then we have to draw a compass rose. Because it says from M, we draw a compass rose around the M. 260 degrees. It's less than 270. So it'll be roughly around over there. This is going to be around 260 degrees. And of course, P will be here. Looking at C, 335 degrees from X. So again, it says from X, so we draw the compass rose around X. If that's X, I draw the rose, the compass rose. It kind of looks like a compass. You know how this is north, south, and so on. Obviously, we'll be using bearings rather than north, east, southwest. Anyway, 335 degrees. Now, note that that's 0 degrees. That's 90 degrees. That's 180 degrees. That's 270 degrees. And coming back all the way around is going to be 360 degrees. If you go all the way around, it's 360 again. So 335. Well, 335 is between 360 and 270, around over there. So that will be roughly 335 degrees. And P will be over here somewhere. And D is very similar. I'm sure you can give it a go. Let's get question 6, so we don't waste any more time. A yacht leaves Sydney and sails 98 kilometers on a bearing of 77 degrees. So they've drawn it over here. This is Sydney, and the yacht's gone 77 degrees on bearing, right, 98 kilometers. Fair enough. How far north of Sydney is the yacht? How far north is it? Well, this is Sydney, and that is where the yacht is now. So how far north has it come? That's how far north it's traveled. If you go northwards from Sydney, this direction, how far northwards? We're not considering the east side. We're only considering northwards. How far north has it gone? Well, that distance over here. Let's call this X. So let's find X. What is X? Well, that's 90 degrees. And because that's 77, this is going to be 90 minus 77, which is equal to 7. So we can count upwards from 77. 77 to 80 is 3. From 80 to 90 is 10. So 13 degrees. 13 degrees. Okay, so I will actually write down 13 here. This is 13 degrees. Now we can use Sohcahtoa, because we know it's 98. We know that's 13. And we're going to find X. So with regards to this angle over here, that is the opposite side. And this is the hypotenuse. So we're talking about sine, soh, right? So soh, because we have opposite and hypotenuse. Sine of 13 is equal to opposite, which is X, over hypotenuse, which is 98. And that's a calculator question. You should be able to figure that out. Multiply both sides by 90 and so on. So let's look at question 7. So most of these questions are just about interpreting the wording of the question to make a diagram. And when you have a diagram, you have to find the right angle. Find the right angle and try to apply Sohcahtoa. Let's look at question 7. Colin leaves work and drives 204 kilometers to Nyngan. The bearing of Nyngan from Burke is 127. The bearing of Nyngan from Burke. So this is Burke, from Burke, we draw the compass rose, and then 127. So clearly that is 127 degrees. Another way to think of it is from northeast, right? The northeast is 90, and that extra bit is 127 minus 90. Once again, counting up from 90, 10 plus 27, 37. This is 37 degrees over there. All right, moving on. Find the value of theta. Well, okay, let's draw a triangle. We have a diagram. We have to find a right angle triangle. If we finish off the triangle here, we can clearly see that's going to be 90 degrees. And if that's 37, theta is equal to 90 minus 37, because it's a triangle. And if that's 90, then these two have to add up to 90 degrees as well, because the angles in a triangle add to 180. Moving on, and you can use a calculator for that. How far south of Burke is Ningen? How far south is it? So south is going to be that distance over here. Let's call that x. If that's x, with regards to this angle over here, x is going to be opposite. And then what other information do we have? Drives 204 kilometers to Ningen. So that's 204. 204 is the hypotenuse. So we have the hypotenuse, and we have x, which is O. Once again, we have Soh. In other words, sine of 37, and we are doing b over here. Sine of 37 is equal to opposite, which is x, over the hypotenuse, which is 204. And once again, it's a calculator question. You should be able to solve that. What is the bearing of Burke from Ningen? From Ningen. Okay, well, from Ningen means we draw a compass rose at Ningen. Wherever the from says, from Ningen, we draw a compass rose around from. And what is the bearing of Burke? Okay, well, we have to go all the way around. What was theta over here? Because the bearing that we're trying to find is clearly going to be 360 minus theta, because the whole thing adds up to 360, and 360 minus theta will give you the bearing that we're after. And I'm assuming you got theta over here, 90 minus 37, 360 minus theta, and once again it's a calculator question. You got C from A, you had theta, and you said 360 minus theta, and you get the answer. Moving on, Jayna cycles 10 kilometers due west. Okay, so let's say Jayna starts over here and cycles 10 kilometers due west. Now, of course, if you've got a north, east, south, west, you'll be surprised how many students make this mistake. You can help just drawing this out, just to make sure. So it cycles 10 kilometers due west. West, this way, 10 kilometers. And then 7 kilometers due north. So from here, you go north for half 7 kilometers. 7 kilometers. And we're over here now. How far is Jayna from her starting point? Well, how far is she? That's the hypotenuse right there. We've drawn a diagram. We've tried to find a right angle triangle. We found one. And let's label what we have. How far is Jayna from her starting point? Well, we don't have an angle, so we can't use Sohcahtoa. And they don't want us to find the angle, in which case, like, we can use Sohcahtoa to find an angle, but they don't want us to find an angle. They want us to find the distance from her starting point. And that's just Pythagoras' theorem. So you'll have A will be 7 squared plus 10 squared will equal to, let's call that C squared, and that's just a Pythagoras' theorem question. You can do it on a calculator. What is her bearing from the starting point correct to the nearest degree? Now we might have to use Sohcahtoa. So if you have this, let's draw it from her starting point, from the starting point. So we draw the compass rose at the starting point. Compass rose there, and the bearing is going to be that bearing there. So how are we going to find that bearing? Well, we know this here is going to be 270. We just need to find that angle there. If we can find that angle and we add, let's call that theta. So 270 plus theta is our answer. But what's theta? Well, we have the opposite and we have the adjacent, so that's going to be tan. Tan of theta is equal to opposite, which is 7, adjacent, which is 10. And then we find the inverse tan on both sides, so theta is going to be the inverse tan of 7 over 10. Make sure you add that to 270 and you'll get the answer. Question 11. A triangular orienteering run starts at Alpha and passes through the checkpoints of Bravo and Charlie before finishing at Alpha. Okay, so it's triangular orienteering run. You don't need to know what that is. It's just triangular. It's a run of some sort. It starts at Alpha, and it passes through the checkpoints of Bravo and Charlie. So I'm just drawing a draft triangle. Let's say it goes through Bravo here. That's A, B, goes to C, and then comes back to A. Okay, so that's a draft version. If they give us, so they're giving us directions. So clearly, that this may not be the this is not a correct diagram. Sorry about my son. So let's draw that. Let's draw it again. We know roughly it's going to be a triangle, right? Let's actually draw it. Bravo is 8.5 kilometers due east of Alpha. So if Alpha is there, Bravo is east. In other words, it's eastwards. This direction is Bravo. And Charlie is 10.5 kilometers south of Bravo. So south of Bravo is you have C. And then it goes back to A. So that's the triangle. Calculate correct to 3 decimal places the distance from Charlie to Alpha. We have to calculate the distance from Charlie to Alpha. So this is the distance that we're after. Let's call that X. Let's fill in the triangle with the other information that we received. Bravo is 8.5 kilometers due east. So that's 8.5 kilometers. And Charlie is 10.5 kilometers south. So that's going to be 10.5. And clearly this is just going to be a Pythagoras. At least A is just going to be a Pythagoras theorem. 8.5 squared plus 10.5 squared is equal to X squared. I mean, you can call it C if you want. It doesn't really make a difference. Anyway, that's Pythagoras' theorem. I'm sure you should be able to solve that. Let's look at B now. Find the bearing of Alpha from Charlie. From Charlie. So again, draw the compass rose at Charlie, and we're going to find Alpha. So it's going to be this angle here, and that once again it's going to be 270 plus whatever that is. Okay, so 270 plus, let's call this theta, as always, theta. Well, how do we find theta? Well, there's a couple of ways you can find theta. You can find, see this angle here, we can call this angle there, we can call that, whatever that symbol is called. I forgot, I think it's alpha. That's alpha. Okay, let's just say that's alpha. So we can find alpha and then a 90 degrees minus alpha. Alternatively, you can notice that this is an east-west line. And this was also east, directly east, right? And therefore this line there and this line there, they are parallel. And therefore this, and this, the double line, they are alternate angles. So this will also be alpha. So we can use the triangle that we have to find alpha or theta. Either way, we'll be able to then find alpha. And then we'll be able to find alpha and then theta, but you get the idea. You do 270 plus theta and you'll have the answer. So what should we do? Well, let's think about it, and we'll just choose one at random. I'll just wipe all of this off. Alright, let's see, what should we do? Okay, let's keep it simple. I'm just gonna find this one over here because for no reason. Tan alpha is equal to, oh yeah, it's tan because it's TOA, opposite adjacent. We don't have the hypotenuse. I mean, we do. You found it at A. You found the x at A. But let's just use the information that were given to us. Opposite, which is 8.5, over adjacent, which is 10.5. And then you find the inverse tan of that, and you'll find alpha. And then once you have alpha, you can just do 360 degrees minus alpha, and that will give you this bearing right there. Okay, so 360 degrees minus alpha equals to the answer. And I'll leave that for you. Question 13. A fishing trawler sails 30 kilometers from port on a bearing of 120 degrees. So let's say you have the fishing trawler right over here. This is where it started off. Goes on a bearing of 120 degrees. 120 degrees is going to be roughly that way. On a bearing of 120. So that is 120 degrees. How much did it travel? 30 kilometers. 30 kilometers. Until it reaches a submerged reef. how far to the nearest kilometer is the port north of the reef? So it left the port. So let's label that P. And this is the reef. Let's label that R. Okay. And let's look at the question. How far is the port north of the reef? Okay, well, if you think about it, that's how far north the port is. Remember, when it says north of the reef, it's saying don't consider the east-west direction at all. Only consider the north direction. How far north is it? Well, let's draw a triangle. We have a diagram. Let's draw a triangle. And the most obvious triangle is this triangle over here. Okay. Sorry for the rough sketch. Now, 120 degrees. That was 90, and therefore this has to be 30 degrees. Because the northeast, see, that is going to be 90 degrees. And then plus, if 90 plus something is 120, that something must be 30. And that's why it's 30 over here. And they want us to find north of the reef. Let's label that X. So with respect to 30 degrees, that's opposite. And we have the hypotenuse, because that's the right angle triangle. 30 is going to be the hypotenuse. So we have Soh, and therefore we're going to do sine of X, sine of 30 degrees, sorry, is equal to X over 30 kilometers. Take 30 over and you should be able to solve it. That's A. Let's have a look at B. How far is the port west of the reef? Well, west of the reef is going to be this direction, up to around over here, that direction there, right? Well, the hypotenuse is 30. Let's just draw another triangle, just so we can see it a bit clearer. How far west is it? In other words, we want to find y. Of course, you could have used the original triangle, label that y. It's the same thing. Let's just use this one. Remember, this is 90 degrees. If that's 30, alternate angles means this is also 30. Another way to think of it is, because that's 30 degrees, this has to be 60 degrees, right? Because it's a right angle triangle up there. 30 degrees, 60 degrees. Let's do it with respect to 60 this time. Instead of using alternate angles, we just use a right angle is 90 degrees. So what do we have? What information do we have? We have the 30 kilometers is the hypotenuse, and we have the opposite. So once again, opposite hypotenuse, sine of 60 is equal to opposite, which is y, hypotenuse, which is 30. And once again, that's just a pre-question. You should be able to solve it fairly easily. All right, last question for today's session. 2 racing pigeons are set free at the same time. The first bird flies on a course of 40 degrees. So the first bird is going something like there, 40 degrees, right? That's the bearing. That's 40 degrees. While the second bird flies on a course of 130. Well, 130 is going to be roughly over there. And this is the angle we're talking about. That's going to be 130 degrees. The first bird flies 200 kilometers. So it goes 200 kilometers until it is flies 200 kilometers until it is due north of the second bird. So flies over there, and it is now directly due north of the second bird. There is a direct line. You can draw a direct line. It's completely north. Find their distance apart corrected to 2 decimal places. Well, 40 degrees, 200, 130. Let's think about this. It's directly north. Okay. So how much is this going to be? This angle over here. That's going to be 130 minus 40, which is 90 degrees. And hey, great. Guess what? We have a right angle triangle right there. And that makes stuff a lot easier. That's a right angle triangle. And we know this is 200 because that's how far it flew. 200 kilometers. And that's 90 degrees. And what other information do we have? 130 degrees, that's 90. Yes. We said that was 40. That was 40. And using alternate angles, we know that if that's 40, this also must be 40 degrees. And so in our triangle, we have 40 degrees. And we want to know, find their distance apart. This is where the first bird ended up. This is where the second bird ended up. And this is what we have to find. So with respect to the 40 degrees, we have the hypotenuse. Remember, the hypotenuse is opposite the 90 degree angle. So we have the hypotenuse and we have the adjacent. So it's a cat question. Cos of 40 degrees is equal to adjacent, which is x, over the the adjacent is 200, my mistake, over the hypotenuse, which is x. And then once again, just x goes over there, cos 40 goes there. That's just a calculated question. I'll leave that for you. Second part, how far has the second bird flown? In other words, they want us to find y. Well, to find y, I mean, that's how far the second bird has flown, right? They both started off here. The second bird went this way on a bearing of 130 degrees. And it ended up being due south of the first bird. Well, let's find y. With respect to 40 degrees, the opposite is y. So we have opposite and we have the adjacent. And that's clearly a TOA, tan question. Tan of 40 degrees is equal to opposite, which is y, adjacent, which is 200. And once again, you just take the 200 to the left-hand side, multiply both sides with 200, and it's just a calculator question. So I hope it helped. The only real tip I can give you is read the question very carefully, draw a big diagram, find a triangle, a right angle triangle somewhere in the question in the diagram, and then see if you can apply Sohcahtoa. That's really all there is to it. There's no real big secret. Sometimes some things just require practice. So if you're struggling with this topic, just practice more. There's no other secret in mathematics apart from practicing. So best of luck, and as always, if you need help, you can ask me on Slack. Assalamu alaikum.